Check sound is up, sound is up.
Right, and I3 is playing up again. So let's get to it. Make the most of this next hour. How do I move? Here we go. Are we back where we were? I think we're back where we are. Okay, so tonight we're probably going to get chapter 2 done and maybe chapter 3. And that'll be it for tonight. Got some... Oh, wait, we'll see. We've got a timer, so we'll just go off the timer and see how things go. Not the plan I originally had, but we'll go with it. Right, so back with functional programming on Boot.dev. And we got to here, and we got to reduce the reducer lesson. So the built-in function, functools.reduce function takes a function and a list of values and applies the function to each value in the list, accumulating a single result as it goes. Like that. Yep, so they import the functools from the standard library, functools, definition add, some so far. Yeah, functools reduce. Notice that we're passing add without the brackets. Brackets, it means that reduce will take care of the execution and pass the parameters for you. Think of passing add like handling someone a recipe, the instructions, instead of the finished dish. The result of the execution. Assignment, complete the join and join first sentences functions. Join. So this is a helper function we'll use in join first sentences. It takes two inputs. The doc so far accumulate a string. It's similar to sum so far variable in the example above. Sum so far. Sum so far variable in the example above. A sentence string. This is the next string we want to add to the accumulator. It returns the result of concatenating the doc and the sentence strings together with a period and a space in between, for example. Doc sentence will return this is the first sentence, this is the second sentence. Okay, so that's easy enough. So we're just going to do return. And we do is like an F string. F string like this, and it's going to be, is it doc so far, space, and then sentence. Just run it, just see what it does. And then, so I think that's just right off the bat. And then join first sentences, it accepts two arguments, a list of the sentence strings, an integer n. It should use the built-in functools reduce function alongside your join function to return a single string, the result of the joining the first n sentences in the list. It should also add a final period but no trailing space to the end of the final reduced string. If n is 0, then return an empty string. So off the bat we can do like if n is less than or equal to 0, then return blank string. Use list slicing to get the first n sentences. For example, print proof sentence. Here's an example of the expected behavior. Okay. So we're going to so off the bat, I think we're just going to basically return, and as a f string, and we're going to do join. I'm going to pass it I'm going to do n like that. But we might have to do a loop of some kind. Hold on. You should use the built-in reduce func tools reduce function alongside your join function. Okay, so we're not going to need that actually. So we're going to use func tools dot reduce. Just looking at how it's used there. So we're going to pass the join function and then sentences. Oops. Sentences. That's going to be n like that. And we're just going to run it and just see what it does. So expecting I don't feel safe. Are you cussing with me? It's just got an extra period at the end, so I guess we can just do right. Is it right strip or strip like that? Does that work? Nope. So we almost got it. It just needs to not have the full stop at the end. Oh, expecting. Hold on. Hold on. It says expecting. Are you cussing with me? Suppose we can just so it passes that. Is it going to submit though? Hey, it worked. I was a bit surprised because like I didn't expect to have the extra period on at the end after the question mark would make sense, but it's their thing, so it is what it is. So map, filter, and reduce review. So high order functions like map, filter, reduce allow us to avoid stateful iteration and mutations of variables. Take a look at this imperative code that calculates the factorial of a number. So factorial takes n, a procedure that continuously multiplies the current result by the next number. So result equals 1 for I in range of from 1 to n plus 1. Result times I. Return result. Here's the same factorial function using reduce. So import func tools, define factorial n, func tools dot reduce lambda x y, x times y to the range of that. Okay. In the functional example, we're just combining the functions to get the result we want. There's no need to reassign variables or keep track of the program's state in a loop. A loop is inherently stateful. Depending on which iteration you're on, the I variable has a different value. So that's the part I struggle with sometimes. Whenever there's certain situations I struggle to deal with where with like not using a loop. So which is the imperative way to apply changes to a list of items, a function? Oh, imperative. Sorry, I was thinking declarative in my head. Yeah. Okay, same thing again, just another question. What's the primary advantage of composing functions instead of using loops? TJ will finally be proud of you. Maybe he will. Performance composing functions is faster than loops, not necessarily. Avoiding stateful mutations, which can be harder to debug and reason about. Let's say that one. Okay, so we got 3 challenges now. Intersect, zip, and restore on this chapter. So let's give it a crack. Intersect. The intersection method calculates the intersection of 2 sets. The intersection of 2 sets is a new set that contains all of the elements that are in both original sets. For example, A and B, 1, 2, 3, 4, 3, 4, 5, 6. C equals A intersection B, print C. Assignment. Complete the get common formats function using the dot intersection method. It should take 2 arguments, formats 1 and formats 2, each a list of strings representing the file format supported by 2 different pieces of software. It should return a set of strings representing the file formats that are supported by both pieces of software. So it's not just a case of return formats dot intersection formats 2. No case of that? Nope. List. Okay, so we've got to turn them into sets first. I can't. How do we do it into set again? Is it just like that? Set? Expecting actual. Is that it? Literally just did it off the bat. Boom! Just wrap a set around it. What's their solution? Is that just the same as ours? It's just the same as ours. Zip. Zippity-doo-dah, zippity. The zip function takes 2 iterables, in this case lists, and returns a new iterable where each element is a tuple containing 1 element from each of the original iterables. So listing is it. So assignment. Complete the pair document with format function. It takes 2 lists as input, doc names and doc formats. Each list contains strings. The doc names list contains the names of documents, and the doc formats list contains the file formats of the documents. First, zip up the lists into a single set of tuples with the names as the first index and the formats as the second index of the tuple. Next filter, right, okay, so first part is just return, just going to zip doc names, doc formats. See what it does. Okay. Next filter the list of tuples. To only include tuples where the format is one of given valid formats. And I already have forgotten how filter structured. We get filter. And then we give it don't think this is quite right. Filter object hat. Takes two lists, doc names and doc formats. Each list contains strings. Doc names list contains the names of the documents, and doc formats list contains the file formats of the documents. First, zip up the list into a single set of tuples, with the name as the first index and the valid formats as the second index of each tuple. Next, filter the list of tuples to only include tuples where the format is one of the given valid formats. Return the result as a list. So then, filter. So valid formats, that, and then so then we just want to turn it into a list. List object is not callable. Okay, not quite. So let's take a function as that part first. So it does it right. So valid formats. Yeah, I didn't think it would be. I mean, I think it is this. So it's so I think we need to write another function for this. So define. It's going to be filter valid for formats. So doc object. Just for now, just when doc object return, just see what it does. Okay. So then we just want to remove formats when given format. So how best to do this? So Hold on. Am I doing this the wrong way? I think I got the wrong end of the stick. Oh, I can just pass the lambda function. Forgot about that. So doc object, and then how do you get the key of something again? I forgot. Is not in. This might is not in valid formats like that. Not in. Hold on. Indexing into lists. Forgotten how to reference it. Oh, do you let's just do it like that? Doesn't feel right. Hold on. Python check if not in tuple. You can write not in Python check if it is absent from a collection. It's not in. Is that not it? Python check if in array. Yeah, if in. It's definitely that. Just not filtering out like I expected. Expecting. Oh, hold on. It's checking the wrong thing. Whoops, no. Doc object. There we go. Wrong way around. Okay, so I think I got it now. Hey, let's have a look at their solution. Is it a one-liner? Not quite. They do zip first, and then they basically do what we did. Lambda. Oh, they zip it, then turn it into a list, and then they filter the zipped list. They do the same thing basically as us. Yep. Last challenge in this one, in this chapter. Okay, restore. Doc2Doc needs a way to restore documents from saved backups. However, not all original documents may have backups, and some backups might be corrupted. Complete the restore documents function in one line if you can. It takes 2 tuples of document strings, originals and backups, as input and returns a set. So convert all documents to the same case with the upper. So return convert all documents to the same case using upper. Convert all documents to the same case using upper for comparison. Turn it to the list so we can see it. Okay. Hold on, I know what it's trying to do. Does that work? And x x x. So let's read it all the way through because I got a feeling it's like mixing us up by not kind of doing it the right way. So convert all documents to the same case using upper for comparison. Filter out documents that are corrupted strings of random numbers with is digit. Return the combined originals and backups tuples, removing any duplicates from using a set. Okay. Start again with this, I guess. So let's start from the beginning. So we have a list of these return combined rates tuples using set. So originals, backups. What does that do? Convert all documents to the same case using cross and upper. Filter out documents that are corrupted, strings, random numbers is digit. Return the combined original and backups tuple, removing any duplicates using set. So we're going to do map, and then we're going to do lambda function, lambda item equals item. Map that all, and return it as a list. It's all uppercase, and then we just do return a set from that. So then a set of that. One pass, one fail. Map. Oh yeah, so map them all to uppercase. Going to filter them. Filter, we're going to do same lambda again, lambda function. It's going to be another item. And then if item dot is digit, say not is digit. Passed. Okay, think. Does that hit the spot? It does. Let's have a look how they do it. Okay, so they put nice formatting around it. I didn't do that for mine. So they return a set because they know they want a set at the end. They filter. Okay, first they turn it into a map. They map everything from originals plus. Oh, they just combine the two. So plus them together, and they map over it, and they change everything to Docker to upper. And then they do the same thing I did, and pretty much the same. Woo! There we go. Well, I have not figured out sound and connecting my Bluetooth headphones yet. I've not had a chance to do that. I'll do that at some point next week. But for now, I'm sorry guys, I'm just gonna have to listen to it, and you guys will have to just enjoy the peace and quiet. And I also need to sort out this double polybar thing as well, which is kind of annoying, but anyway. So pure functions says, if you take nothing else away from this course, please take this. Pure functions are fantastic. They have two properties. They always return the same value given the same arguments. Running them causes no side effects. In short, pure functions don't do anything that exists outside of their scope. Let's listen.
always return the same values given the same arguments, and they cause no side effects. Let's get to the first point. Here's an example. We have an add function that takes A and B as input and returns the sum. Now, no matter how many times you call add with the same arguments, you'll get the same result. I'll add with 2 and 3 1 trillion times in a loop, and you'll go crazy waiting for anything but 5 as the result. Now let's take a look at a similar but impure example. First, we'll declare a global variable called result and set it equal to 0. Next, we'll define a function called add2result. Now this one only takes one input, we'll call it A. The first thing it does is declare that the result value, or I should say the result variable, is a global variable. In Python, this is required just so that we're allowed to access that global variable from within a function. Next, we'll add A to the result and return that sum. Now, the interesting thing about this function is that every time you call it, even with different inputs, you could potentially get a different result. For example, the first time I call to result with, say, the number 5, I expect to get back 5, because we're going to add 0 to 5 and return it. But if I call add to result again with the input 5, I won't get 5, and that's what makes it impure. Because the result variable now has 5 in it already, we'll be adding 5 to 5, and we'll get back 10. And this is why pure functions are so convenient to use in the majority of cases. Every time you call them with the same inputs, you expect the same outputs. You don't have to worry about there being hidden random number generators, the state of the database, or whether or not an internet connection is available in order for the function to work as expected. And because they're predictable, they're easy to test and debug. You can write an entire suite of unit tests for a pure function, and assuming they pass, you can expect, not just expect, but they will work the same way in production given the same inputs. If you've ever experienced the, well, it works on my machine meme, that's not a problem with pure functions. Impure functions are the ones that made that meme popular. So if pure functions are so great, then why don't we just make all functions pure? Well, by definition, pure functions can't have side effects. And a program that has no side effects is effectively useless. It just makes your computer heat up, but to no result. If your program has no side effects, it can't even print to the console. It can't access the internet. It can't update a database. It can't even draw buttons on a screen. So what should you do? Well, my rule of thumb is I try to make as many of my functions that can reasonably be pure, I try to keep them pure. And I try to keep the number of side effects in my code contained to just a few places, usually somewhere near the top level of my code. That way, when other developers are working with my code, it's obvious where the side effects are, and everything else is fairly easy to test and debug.
Yep, it's a good rule of thumb. I don't think anybody can argue with that. Yep. Here, you get no complaints from me. So example of a pure function. Yep. So just given the same inputs, we'll get the same output. Example of an impure function. So global variable assigned. Assignment. There's a bug in the convert file format function. Right now, it relies on data outside its own scope. These global values can be changed by other parts of the code, so they're not guaranteed to be the same every time convert file format is called. Fix the bug by calling convert file format a pure function. It should only depend on data that is scoped inside of the function. It's pretty easy. So this one. So valid extensions. Yeah. Is there anything else it uses? Valid conversions. It does use both. File name, target format. There's two ways we can do it. We can either put these two things into the function, or we can just add them as arguments. So valid conversions and then valid extensions. Let's see how that does. Blah 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 blah. Missing two required positional arguments, right? We can't do that, so that's not what it's expecting. So we can do just move it inside. I think that's what it might be expecting us to do. Bingo. Easy peas. Pure function review. So, how many things are in this one? Ooh, quite a lot actually. Yeah. Okay. Maybe we don't get this all done in the time we got, about another like half an hour or so. Just a short one tonight. Just got things going on. So, pure function review. Pure functions have a lot of benefits. Whenever possible, good developers try to use pure functions instead of impure functions. Remember, pure functions return the same result if given the same arguments. They are deterministic. Deterministic means in mathematics computers, a deterministic system is a system with no randomness is involved in the development of future states of the system. A deterministic model that will thus always produce the same output given a starting condition or initial state. Do not change the external state of the program. For example, they do not change any variable outside their scope. Do not perform any input-output operations like reading from disk, accessing the internet, or writing into the console. These properties result in pure functions being easy to test, debug, and think about. Refer to the following examples and answer the questions. Example 1. Multiply by 2 nums products is an array. For num and nums, products append, blah, 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 blah. Example 1 is pure. And then example 2, balance, cars, definition by car, new car, cars, append. Yep. So it's immediately referencing the thing outside of it, and it's also referencing the balance. So it's impure. And the next one, the last one, example 3, import random. Well, it's got a whole random event in it. Basically randomness. So I would say it was impure, even though it's only using the inputs that's given. It's impure. Has side effects. This is basically like got other variables and things outside of it. Although I want to explain that one, that'd be a nice one. Explain this multiple choice question. So let's examine the third example to determine whether it's a pure or impure function. Remember, a pure function must return the same result given the same arguments, not change external state, not perform input-output parameters. Looking at dice roll, you can predict that you return every time you call it with the same input. For example, if you call roll dice 6 multiple times, you could always get the same number. No, the function uses randint, which generates a random number between 1 and number of slides. That's why. Okay, reference versus value. When you pass a value into a function as an argument, one of two things can happen. It's passed by reference. The function has access to the original value and can change it. It's passed by value. The function only has access to a copy. Changes to the copy within the function don't affect the original. There is a bit more nuance, but this explanation mostly works. These types are passed by reference. Lists, dictionaries, sets. These types are passed by value. Integers, floats, strings, booleans, tuples. Most collection types are passed by reference, except for tuples. And most primitive types are passed by value. Pretty sure it's the same with JavaScript. So example of passed by reference, which is mutable. So in a list, so it passes the outer list, and that append actually modifies the outer list, this one. And passed by value is immutable, so in a num. So an outer num, inner num, inner num. The original outer num is not updated because the inner num is a copy of the original. Assignment. We have a way for doc-to-doc users to set their supported formats in their settings. In memory, we store those settings as a simple dictionary. Unfortunately, there's a bug in our code. There's a code in our bug. Imagine. Unfortunately, there is a bug in our code. When a new format is added or removed, it not only updates the new dictionary, but it changes the defaults themselves. That's not good. We want to create a new dictionary with the updates, not change the original. Fix the bug in making add format and remove format pure functions that don't mutate their inputs. add format, new, so formats equals hold on. How do you copy something? Is that what it's going to tell me? Yeah, I thought so. Simply assigning a new variable to an existing dictionary doesn't copy that dictionary. It points to the same dictionary. Instead, use the copy method to create. Yeah, I thought so. I thought we were going to have to copy something over. So this one's going to be new default, new formats. It's going to be like this. So new underscore formats. It's going to be default formats dot copy. It's basically just going to be the same over here. Let me change all these, and it should just work. Yay! So copy the object first, then basically just mutate the one that's already there. Let me see what they did for their solution. They did something different. No, they literally just did the same thing. Okie doke. Wasn't through this one. Might get to the end of it. Who knows? Chapter 3. There's a lot going on. Like these chapters, but it's good. So pass by reference impurity. Because certain types in Python are passed by reference, we can mutate values that we didn't intend to. This is a form of function impurity. Remember, a pure function should have no side effects. It shouldn't modify anything outside its scope, including its inputs. It should return new copies of inputs instead of changing them. Pure function. Yeah, creates a copy, makes the change, basically just what we did before. An impure function doesn't modify the mutation. Why do we care? One of the biggest differences between good and great developers is how often do they incorporate pure functions into their code. Pure functions are easier to read, easier to reason about, easier to test, and easier to combine. If you're working in an imperative language like Python, you can and should write pure functions whenever possible. There's nothing worse than trying to debug a program where the order functions are called needs to be just right because they're all read and modify the same global variables. A pure function can mutate global variables, mutate its inputs, mutate global variables, call functions that mutate global variables. Oh wait, sorry. Mutates local variables. Whoops. I jumped the gun on that one. And the second thing was pure functions should be avoided at all costs, execute faster, easy to debug, read, and test. Not necessarily faster. Input and output. I'm glad you're including more comments in your code, but it would be nice if they were comments about your code, or at least a bit less obscenity filled. Look, they say to write what you know. All the functions you've written take everything passed to them and return it unchanged with the comment, no, you deal with this. It's a functional programming thing, avoiding side effects. You avoid all effects. Only way to be sure. I like that comic. That's funny. The term I/O stands for input-output. In the context of writing programs, I/O refers to anything in our code that interacts with the outside world. Outside world just means anything that's not stored in an application's memory, like variables. Examples of input-output. Reading from or writing to a file on the hard drive, accessing the internet, reading from or writing to a database, even simply printing to the console is considered input-output. All input-output is a form of a side effect. Assignment. In doc-to-doc, we frequently need to change the casing of some text. For example, title case, lowercase, uppercase. There is an issue with the convert case function. Our test suite can't test its behavior because it's printing to the console. Ugh, a side effect. Instead of returning a value. Fix the function so it returns the correct value instead of printing. Okay, it's as simple as woohoo! Easy peasy. Easy squeezy. There we go. Should I input output? A program that doesn't do any input output is pretty useless. What's the point of computing something if you can't see the results? I'm a functional programmer. What's that mean? It means he is scared of side effects. I am not. Ooh, print! Stop it, you're scaring him! I love that. SpongeBob. Hey, Patrick. Hey, SpongeBob. In functional programming, input-output is viewed as dirty, but necessary. We know we can't eliminate I/O from our code, so we just contain it as much as possible. There will be a clear place in your project that does nasty I/O stuff, and the rest of your code can be pure. For example, a Python program might read a file from the hard drive as the program starts, run a bunch of pure functions to analyze the data, write the results of the analysis to a file on the hard drive at the end. So impure, pure, 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 impure. So input-output should work in functional programming, strewn all throughout the project. Only used when Simon Peyton Jones isn't looking. Limited to specific parts of the code base. Avoided completely. Limited. Which is a necessary evil. From the user's perspective, a program with no input output is fast. Does nothing. Can read only from external database. Can only print to the console. Does nothing. Whizzing through these. Yeah, I've got 14 lessons and 3 challenges. We might. Nah, maybe not, but we'll get close. A no-op. No-op. So a no-op is an operation that does nothing. If a function doesn't return anything, it's probably impure. If it doesn't return anything, the only reason for it to exist is to perform a side effect. Example of no-op. This function performs a useless computation because it doesn't return anything or perform a side effect. It's a no-op. So define square, x times x. Example side effect, this function performs a side effect. It changes the value of y variable that is outside of its scope. It's impure. It's pure, but it does nothing. The global keyword just tells Python to allow it to access the outer scoped y variable. Print. Even the print function, technically, has an impure side effect. It doesn't return anything, but it does print text to the console, which is a form of input-output. Assignment. Complete the remove emphasis from line, and remove emphasis from word functions. They are currently no ops. Remove emphasis is the parent function. It takes a full document with any number of lines and removes any single or double asterisk characters that are at the start or end of a word. Emphasis in Markdown. For example, this, I love Markdown. I really love Markdown. Should become that. Okay, write the helper functions. They will make the remove emphasis function much easier to write. The remove emphasis word function should remove emphasis from a single word. So, okay. I think it's just a case of return word dot strip. That's going to be oops. Where's the asterisk on this keyboard? Not to use it yet. There it is. Got it. Move from line. From a single word. The remove emphasis from line function should split a given line into words and use the function we create to remove the emphasis from each word. Don't forget to handle new line characters properly at the end of lines. So I think it's just going to be a case of return, and we're going to use the remove word strip one, like so return line dot split split. Is it just like space? It's going to be like whoops. It's going to be map. That's going to be remove emphasis from word, like that, from that thing. And then let's just see what it does when we do this. So remove emphasis from line. It's going to be doc content. Just see what it does. Just do join like that. Whoops. Python list join. Oh, I'm a dum-dum. Just goes around it like that. Hold on. Oh, delete. Yeah, that's pretty much it. Whoops. Not quite. Which ones are failing? So pass, fail, input. Because I'm not doing. Where did it go wrong? Hold on. Failed twice. So pass, fail on this one. So input a document. Forger running into a penguin. Expect out Forger running into a penguin. Forger running into a penguin. So just a case of doing left strip and right strip. It's the same thing, isn't it? And I guess if we like strip it, or strip any, this might be a little bit overkill, but nope, still not working. Uh, is it because it's a number? Let me have a look at a tip. Sake of practice, try it without the replace string method. Use some of these built-in, so string split. Yeah, I did that. Strip, map, join. Yeah, basically just used all of those. So is it something to do that? No. We're just missing something simple, I feel like. I don't want to get stuck for too long. I think it's just going to be something like, oh, well, look at that. Oh, it's so obvious. Why didn't I don't know that? What edge case am I missing? Go on, Boots, tell me. Help me panda your enchantment challenge. Seems there's a sneaky edge case lurking in the shadows. Look at the test. There are cases with multiple lines and new line characters at the end of sentences. The most common issue students encounter with this problem is handling new lines properly. When splitting a document by lines and then rejoining them, you need to be careful about preserving those new line characters. For example, if you take blah 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 and just split by n, you'll get an array of lines. When you join them back together, and you'll need to make sure you're not losing any trailing new lines. Can you share your current code? Yeah, sure. I see the issue now. Your implementation has a key oversight that handles multi-line documents. Let's look at the word. Looks good. Strips asterisk characters from the beginning and end of the words. Your remove emphasis line also looks reasonable, but there's a subtle issue by using split with a space instead of using split. Oh, this might affect how. Hold on. Can you do it like that? I didn't realize. Nope. The main problem is your remove emphasis function. You're treating the entire document as a single line by passing it directly to the thing. Doesn't preserve the line structure of the document. So is it just a case of mapping? So I just need to like map. Split. And then we just turn it back together again. So like join. Then we just do like that. Nope, not quite. It's because of that. Ah, no, what's going on? Split the document into lines. Hold on, is it because it wants to be like new line? Like that. Right, okay. Is this it? It is it. Right, let's have a look how they do it, because it's a little bit messy, that. Words, line, split, words. So new words, map. Yeah, it's basically what I did there. But except they didn't do a split with the things in it. And what did I do? Yeah, pretty much the same, but just on a single line. Yep, okay, no props. Basically just did the same thing. Lesson 12. Right, we've got 3 lessons left. We'll complete these 3 lessons, then we'll call it a night. It's going to be an early one just because got some things to do. Okay, so memoization. At its core, memoization is just caching, storing a copy of the result of a computation so that we don't have to compute it again in the future. For example, take this simple function, add x and y, return is plus x and plus y. A call to add 7 will always evaluate to 12. So if you think about it, once we know that add 7 can be replaced with 12, we can store the 12 somewhere in memory so we don't have to do the addition operation again in the future. Then if we need add 7 again, we can just look up the value 12 instead of doing a potentially expensive CPU operation. The slower and more complex the function, the more memoization can help speed things up. It's pronounced memoization, not memorization. Memoize. This confused me for quite a while in college. I thought my professor didn't speak goodly. Speak goodly. Good one. Counting the words in a document can be slow, so we want to memoize it. Complete the word count memo function. It takes 2 inputs: a document string, a memos dictionary. The keys are full document strings. The keys are full document strings and the values of the word count of the document. Okay. It should return 2 values: the word count of the given document and updated memos dictionary. Okay, so the word count of a given. Here's steps to follow, right? Okay, so they're giving some steps. So create a copy of the memos dictionary. So memos underscore copy equals memos dot copy. Okay. If the document is in the memos dictionary, just return the associated word count and the memos copy. No need to recompute it. So if, doing JavaScript there. So if document in memos copy, then return the associated word count in the memos copy. I think it's like this. So memos copy document and then memos copy. Otherwise, use the provided word count function to count the words in the given document. So I'd say, we don't need to do that. Store the word count in the memos copy. Return the word count and the updated memos copy. So return. Do it like this. So it's going to be memos copy. Hold on. Word count. Word counts. call it document word count. So document word count. Document word count. What does that do? Can't do that. So what's it saying? Unhashable type dict. I've forgotten how to do the multiple returns thing. Hold on. Return. Multiple return values, that was it. Is it? Oh. When you do that, and just do that. It passes a few, but it blows up on one of them. So expected word count. So in input document, spam, blah, 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 spam. Input memos, blank. Expected word count, expected memos. I'm not sure this is right, but let's give it a crack. No, it failed. Yeah, didn't think so. So input this doc should incorrectly have 9,999 words to test that memoization is working. Input memos. My hovercraft is full of eels. 6. This doc should incorrectly have blah 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 blah. Working 999. Expected word count. Expected memos. Actual word count. Actual memos. Wasn't that what I had before? It did run. I was thinking like, yeah, this is a little bit. I don't know why I changed there. Like I thought I already had that working, but anyway, we fixed it. Let's see what their solution was. So it's a little bit simpler. So they do copy like we did. Then if document new memos, that's what we did. New memos document, basically the same as what we did. And then count equals word count that. New memos equals that. Oh, it's basically just what we did, but I don't know what happened that first try. I'm pretty sure we had it. So 2 more, and then we're done for the night. So referential transparency. Pure functions are always referentially transparent. Referentially transparent is a fancy way of saying that a function call can be replaced by its would-be return value because it's the same every time. Referentially transparent functions can be safely memoized. Let's read this again. Pure functions are always referentially transparent. Referentially transparency is a fancy way of saying that a function can be replaced by its would-be return value because it's the same every time. Referentially transparent functions can be safely memoized. For example, add 2, 3 can be smartly replaced by the value 5. The great thing about pure functions is that they can always be safely memoized. Impure functions can't be because they might do something in addition to return static value, or they might return different values given the same arguments. Should I always memorize? No, memorization is a trade-off between memory and speed. If your function is fast to execute, it's probably not worth memorizing because the amount of RAM memory your program will need to store the results will go way up. It's also a bunch of extra code to write, so you should only do it if you have good reason to. Which expression is not referentially transparent as the integer 5? This one. Explain, because it could be a string. Is that why? Cross my curious student. Let's analyze the concept of referential, blah, 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 blah. So the question asks which expression is not referentially transparent, does not effectively represent the integer 5. Let's examine. Add 2, 3. If add is a pure function, we assume it is here. We always return 5. 5 is the number 5, inherently referentially transparent. It's simply integer 5. 3 plus 3 minus 1 evaluates to 5. 2 plus 3 is a string concatenation operation, not an integer addition. The result is 23, yeah. So it's just the fact that it doesn't work like that. Memorization trades memory usage for speed. And we're on to the challenges. Should we knock these off tonight? Nah. I don't think we knock these off tonight. I don't want to get sucked into a black hole. That's going to be the end of that, basically. Cutting it short tonight. Not as long as we normally have things, but it's okay. Just happens sometimes. One thing I want to do, actually, hold on. I want to figure out why my polybar thing is just the way it is. But anyway, we'll call it there for tonight. Tomorrow we'll have a longer session. We'll get way more done. Try and smash out the whole of chapter 3. God, don't know how much we get through. It would be cool to try and get through like all of it, but that might not be a realistic goal, so might not be so. But anyway, that's going to be it for tonight. Thanks for watching. If you've gone back from the future, thanks for coming down. So it's only a short one, but just the way it is for tonight, so no probs. Have a good night. Take it easy.